quadratic formula are great ways to solve problems, but you have to be able to put something in to look like a quadratic. And if you remember, a quadratic is when you have ax squared plus bx plus c. The idea is if you can make it look like that, so that you have something squared, and then what's in the middle is not squared, and then a constant at the end, you can do this for other functions like number 1 here. And so the big part is recognizing, can it be put in quadratic form, and then figuring out what your u is. And so in algebra 2, when we do this, I always say, like, it's really easy to tell if something can be put in quadratic form, because all you got to check is if you square the middle term, do you get the first term, right? Because like on this one, if you take x squared, you get x squared. That works for all of them. So if I take x squared squared, do I get x to the 4th? Yeah, and so that's how you can kind of check to see if something is in quadratic form. And then your u is always whatever that middle number is, because think about in this one, it's always x. So on this one, I'm going to kind of work out the whole u thing. I'm going to say, let's make u equal x squared. And what that means is we can rewrite this problem in terms of u, solve it just like we would a quadratic, but then we have that extra step at the end that we have to plug back in what u was. I just feel like I'm doing very bad grammar when I'm talking about u is and u was. Good math times. So if u is x squared, what does that make x to the 4th become? If I square u, do you agree that becomes x to the 4th? And every time it should work that way. You're trying to make a quadratic, so whatever your u is should make that first one become u squared. And then that just becomes plus u minus 12. And now you're just going to solve it just like before, but then we're going to have extra stuff at the end. And so I'm going to factor this because it's a pretty easy one to factor. And instead of x, now I have u and u. And then that's just going to be 3 and 4, right? 3 times 4 is 12. Positive 4, negative 3. I'm going to come up here just so I don't have to scroll down here. And I would get my two answers, set each of them equal to 0, and I would get that u equals 3 and u equals negative 4. The extra part is, I don't want to know what u is. Like, u is just like our helpful part. You want to tell me what x is. So at the end, after you do u substitution, you have to go back and replace u with whatever you made it equal to, which in this case is x squared. So if u equals 3, that's the same as saying x squared equals 3 and x squared equals negative 4. And then we're just going to solve that. So to solve this, we're just going to take the square root of both sides, and I get x equals plus or minus the square root of 3, because I can't simplify that anymore. I'm not a big fan of this book because we've talked about imaginary numbers, but the homework today says solve and give all real solutions. So on this one, when we take the square root of both sides, we could say that's x equals plus or minus 2i, right? But the book doesn't want that. The book only wants the real solution, so if you get an imaginary solution today, they just say it's not real and we don't give it, and I'm very annoyed by that. But well, the unit test, I was kind of wrong because I have to grade it the way with their answer. So, like, just be aware of it. It's really hard for me. But the directions say find the real solutions of each problem. So, we don't want the imaginary solution. So that actually means less work for you, right? Think of it that way. It's just weird. I don't know why we don't want the imaginary solutions. The different part, I think, from what we did in Algebra 2 is sometimes what they give us in terms of u, I think is a little trickier than just x to the 4th. And so I think I included a few of these. Oh, wait, yeah. I kind of did this already, so I don't know if you need to write this down or not, but we kind of just talked about this, right? Like whatever we pick for u has to fit like this. Solve by factoring, completing the square or quadratic formula, and then replace u back with x. Right, that's what we just did. Do you want to write that down? I'll be quiet a minute if you do. Or maybe I'll double page it for the next, just to get to that. Double page. So if you want to write that, and if not, we can try. I'll make this a little bigger. In algebra 2, we pretty much only kept u with like x to the 4th, x to the 6th, x to the 8th, stuff like that. Every now and again, they might have thrown in a square root problem. But in this book, they kind of want to show you that you can make u really be anything as long as it fits that format. And so this one, I feel like I should do an example of this because it kind of looks weird. But you notice how it has something squared, and then what's in the middle is not squared, and then at the end is just 12. So what would be a good u on number 2? Yeah, and so they have this whole quantity squared, and then this is not squared. And so instead of making u like x squared, this one we can just make u equal x plus 2. And I feel like once you do one of these, you're like, oh, and you recognize it, and it's easy to do the next time, but it's kind of weird at first. And so then I can just rewrite, replace x plus 2 with u, and you just get a lovely little u squared plus 11u minus 12. And then just like before, we can factor, complete the square, or quadratic formula. I feel like most of these today are going to be factorable, not necessarily all of them, but most of them are. And so that's my first method of solving here that I'm going to try. And it's just u and u. 12 again, but now we're subtracting to get 11. So that's going to be 12 and negative 1. Do you agree with that? And again, completing the square quadratic formula would get you the same answers. And I get u equals negative 12 or u equals 1. Biggest thing I have to say, especially when it comes time to a quiz, is just don't forget that this is not your answer. Your answer has to be in terms of x. So your last step is going to be to go back and replace u with what it equals, which in this case is x plus 2. And now you just have like 2 little linear equations to solve. You could have FOILed all this out and probably simplified it and worked it out the same way, but using u substitution is probably a faster way of solving that. So we get x equals negative 12, negative 14, I mean. And if we subtract 2 here, we get x equals negative 1. Agree with that? But that's kind of a problem. Oh, wait a second. Single page. All of this is kind of like the same thing, but it's squared already. So you do this one. X squared minus 1 squared plus x squared minus 1 minus 12. So it's very similar to the last one, only now there's x squared at the end to solve. I don't know. I really don't. I used the examples that the book had in this one. Like normally I pick ones from the homework that I don't assign, but this one I was like, oh, these are good examples, but I kind of didn't notice that they all equal 12. I don't think the next one equals 12, if it makes you feel better. Being really good with our factors of 12. part, I factored and got u plus 12 and u minus 1 again. So u equals negative 12 or u equals 1. Then you have to plug back in the x squared minus 1. Oh my lord, kids. I'm really having lots of brain problems today. That's why I asked you if you're with me, so you check my work here. Oh, thanks. It'd be negative 4. Oh my gosh, are you sure?
Yeah.
So it's plus, right?
But when you plug in u plus 4,
Thanks. I'm just trying to hurry now. Oh, children. What did I do? What did I do in calculus today? Oh, I plotted the point 1, 0 as 1, 1. Like, I didn't even, like, it wasn't anywhere close. I'm like, let's plot the point 1, 0, and then I make a dot out there at 1, 1, and they're like, that's not 1, 0. My brain is not working so well. This is why I do check our work. If we add 1 here, we get x squared equals negative 3, which is going to be complex answers, which means you don't have to do it, right? You can say nothing. It's alright. If you say, I'm not going to mark it wrong, if you say plus or minus whatever I'm just like, it just says real numbers, so I'm trying to make myself not do it. But this one, we get x squared equals 4, and we take the square root, don't forget that it's plus or minus 2, so you really get 2 answers there. Okay? Sorry about my little brain lapse there. Alright, I got one more. Like this one. I might have 2 more. I might be lying here. So we'll see. We might stop. I might just stop after this one. I don't lie. I just forget how many slides I made. I want to do this one because some people see this and they get a little scared of it. But the idea is still the same. If you square this one, does it give you this one? If you take x to the 1/4 and you square it, does it give you x to the 1/2? Yeah. And your u is still always going to be whatever that middle one is. So I could say that my u is x to the 1/4. This kind of goes right hand in hand with radical equations that we did on Friday. So now I can say that this is still going to be u squared minus 4u plus 4. And again, it's factorable. If I can factor this one right. 2 and 2, I do believe. Minus. So I get, there's just one repeated answer here on this one. So I'm not going to solve it twice. It's just the same thing. I get u equals 2. Agree with that? But now I got to plug back in that x to the 1/4. How am I going to solve that x to the 1/4? What would I need to do to both sides? Fourth power, right? Because this is the 4th root already. And to me, I think about, I want this to be x to the 1st power. So what would you need to multiply by? If you multiply by 4, you agree that's how you get x to the 1st? Or if you want, you could rewrite that as the 4th root of x, right? Because remember, fractional exponents are just roots. So then you have the 4th power that side. And we would get, I think that's 16. So I just want to throw in the fractional exponents to show you that same idea. Remember, fractional exponents are roots, radical equations, so you can rewrite them as radicals if you want after you're done. But I would leave them as fractions until you get to the very end if you need to. So like if it helps here, you could write that as the 4th root of x equals 2, and then you do the same step. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. It's really 16. Right? That's like the same as 4 times 4. You're doubting me too much now. 16. It's really 16. All right. Oh, look, I didn't even many problems today? 42 through 60, but that's every third one. And 69. That's eight problems on your homework. Hopefully you don't. Hopefully you can factor better than I can factor. I'm so embarrassed. I was just recording my terrible factoring. Yes. Oh, you have a question? Okay. No. But I'm squaring the power, right? And when you do a power to power, you multiply. See what I'm saying? Like you're not squaring by 4.